So now that we've loaded our tracer data into R, the next thing to do is to define a list of models that we will be using to fit to tracer data. And these are labeled things like model A, B, and C. So while those designations don't tell you a whole lot about the model itself, that's because they reference a separate publication. So if you go back to the website and we click on fitting tracer data, the fifth part was the paper modeling water treatment reactor hydraulics using reactor networks. If you click on that, it'll take you to the website where this paper is saved. If you click on PDF, this is open access. You can download it for free and scroll down to figure 3. And this shows you the different models that we'll be defining, model A through I, single tanks in series reactor with dead space, 2 tanks in series in parallel, all the way down to a PFR and plug flow reactor, tanks in series reactor in series, repeated in parallel with dead space. So these are the 9 models that we'll be defining. And so I won't go through how each of these are defined in detail, but you can look at this if you'd like to understand how these models relate to how they produce the fits that you'll see momentarily. So let's define these models, highlight them all, and click Run. Once we've done that, it's time to perform nonlinear regression. So the nonlinear regression function is called NLS. And in NLS, we specify the model that we'll be fitting it to and what that model is a function of. Again, I mentioned earlier C0 was important to use as a heading because these get factored into the different model fits that we'll perform momentarily. You'll also notice that each model has starting conditions or initial values which you can input, lower and upper bounds. And for this one, I've specified trace equals true. This means that from the time it starts at these initial conditions and before it arrives at its final fit, it's going to print out and show us what each of the combinations of inputs it tries are. So when I click Run, it'll show me the initial estimates that it started with. We'll also then run some code to calculate the mean square and residual squared error. We'll also plot how well that fit worked. So the plot we see here, we've got our tracer data. Now we've got this red line. Shows you how our tanks in series reactor eventually fit to our tracer data. And if you want to see more about that fit, you can type in model A fit, push enter, and that'll tell you that the volume fraction was that it eventually arrived on was 1.026, and the number N of tanks was 5.736. So you'll notice that the volume fraction here is larger than 1. If you go back to the paper, we discuss in detail why that might occur. So moving on with additional model fits, we'll then run the same thing all at once, this time for model B. We'll notice that this produced a considerably better fit compared to model A. So this is model A and model B. So we see that we get a better fit with model B. We'll repeat the same analysis with model C. And based on this appearing, we can see that it's thinking. And unfortunately, it failed to come to a proper convergence on a solution. The more fitting parameters you have, the more difficult it can be to arrive at a solution. And you'll notice that for this one, I've added on something where I've increased the number of maximum iterations up to 100 to try and come to the correct convergence. And so you can toy around with these different initial conditions and see if they allow you to come to a solution. In that case, again, my initial guess failed, and so I'll try a couple different things. And you can keep playing around with these different input parameters and eventually try to get a fit. If you fail to fit a certain model to your tracer data, that's no big deal. The rest of the code is set up to skip over models that you were unable to fit successfully. So I'm just going to run through all the rest of the models real quickly, but remember you can always go back and change these initial conditions to try and get the correct fit. Just in the interest of showing you how this works, it did seem like a great use of your time to watch as I try a bunch of different initial conditions. So we'll run through the rest of the models. Again, they go through I. And we'll watch as it thinks, plot something new. And it's sort of attempting fits with all these different model types. Many of them successful, not all of them. But what we've done here is we've fit a number of the different pre-specified models to the tracer data that we have. In the next video, I'll show you how to output some of that information to an Excel file, such as fitting parameters, statistics, and also these red lines you see here will output those as well so that you can manipulate them and plot them as you like in Excel.